Welcome everyone. Thank you for joining us today for our webinar titled Accelerate and Simplify Data Science Workflow with KNIME and H2O Driverless AI. My name is Patrick Moran. I'm on the marketing team here at H2O.ai. I'd love to start off by introducing our speakers. Paul Treichler is Vice President, Head of Global Partnerships and Corporate Development at KNIME. Stephen Ronner is a Partner Solutions Engineer at KNIME. Stefan Pacinda is a Solutions Architect at H2O.ai. And Rafael Kos is a Community and Partner Maker at H2O.ai. Now, before I hand it over to the speakers, I'd like to go over the following housekeeping items. Please feel free to send us your questions throughout the session via the Questions tab in your console. We'll be happy to answer them towards the end of the webinar. And this webinar is being recorded. A copy of the slide deck and recording will be made available after the presentation is over. And now, without further ado, I'd like to hand it over to Paul.
Great, thanks so much, Patrick, and welcome to everyone. Thanks for joining this webinar. We'll be detailing the joint solution between KNIME and H2O.ai that allows you to accelerate and simplify your end-to-end data science activities using KNIME software and driverless AI. As mentioned, I'm Paul Treichler, VP of Partnerships at KNIME, joined by my colleague Stephen Ronner, who is Solutions Engineer, and Stefan Pacinda, who will be both doing the demo. And Stefan is a Solutions Architect from H2O. So our agenda today continues after the introductions, which are now done with a joint solution overview, a demonstration, and then we'll have some Q&A and some tips for getting started. So who are KNIME and H2O.ai? For the folks that maybe don't have as much background or detail on the two organizations, or maybe are coming from the KNIME ecosystem learning about H2O, or from the H2O ecosystem learning about KNIME, we are leading providers of AI and machine learning tools that are both underpinned by open source, allowing unprecedented access to innovation by data scientists and non-data scientists alike. KNIME, for its part, provides an end-to-end visual workflow tool covering data science creation and deployment. We're headquartered in Zurich with offices in Europe and the US. And H2O.ai's mission is to democratize AI for everyone, and they serve a very broad community with over 180,000 data scientists. KNIME and H2O have been working together for a handful of years already at this point to bring our free open source tools together for various customers and folks within our ecosystems, including H2O3 and Sparkling Water and some of the KNIME tools such as KNIME Analytics platform. And this most recent effort really combines now our powerful enterprise offerings to help companies make better decisions faster. So some of these companies that we like to work with are pictured here, and they cover a very broad range of different verticals, from financial services to life sciences to retail and government, education, manufacturing, and many others. And for these organizations, we're helping them make better decisions. And some of the types of decisions that we're making cover a very broad set of different AI and ML use cases across industries and across different departments. So these include some industry-specific use cases such as drug pipelines or fraud detection, or IoT in manufacturing, to serving different departments like HR departments, finance departments, sales and marketing, et cetera. So you'd really be hard-pressed to find a scenario that we can't handle between the two tools. And coverage of these use cases really means for companies that have a centralized data science capability that's serving the broader business, that you can serve the needs of many of these disparate business units to handle new requests that might have been outside of the original scope of work, but maybe you now need to handle some new request command from a new team. This tool really allows you to provide service to those different divisions. So this, along with the tools for collaboration and governance that are available through KNIME and H2O, give you really a powerful enterprise AI backbone underpinned by open source. And that's really what we're bringing together in terms of our joint solution. In a moment, we'll get to the demo, but before we do, I just want to take a moment to identify some of the problems that companies have in using AI and machine learning that are addressed by the solution. And perhaps some of these challenges you're facing now are in the areas of time, talent, and trust. So some of the challenges of time include things like the breaks in the end-to-end process. So for you, data preparation can end up being disjointed from AI ML, can be disjointed from production and optimization. So this solution really helps bring the process into one visual workflow. For true end-to-end automation, time is also a factor. So this can be difficult process to really do in an end-to-end fashion and drive the automation across the different steps of the data science process. And typically in some traditional settings and in other tools, you need to make compromises along the way to that automation. Some of the other challenges, especially related to talent, include things like human input into the automated process. So if you have some degree of automation in your process, but you want to have user interaction at different points, it's important to have that agility and flexibility to decide which pieces are automated and when human input is warranted. But a lot of the solutions out there really fall short on this promise to allow both guided analytics and then automation where it makes sense. And with this solution, you get the best of both worlds. Also on the talent side, so the tool approach, flexibility drives innovation. There's no one size fits all to data science. So you want to have flexibility and agility, be able to use the different tools or approaches that you need to in your business. You might have coders, non-coders, different business folks that want to be involved in the data science process. And so really having this flexibility and best of breed approach is going to give you a lot more ability to solve your problems in the way that makes sense. And quality. It goes without saying that quality is critical and that your tools should allow you to achieve the highest level of results using the best technology and techniques and innovation available. And this open process really helps you to achieve those goals. And some of the challenges of trust include things like diverse stakeholder involvement. So many different stakeholders need to be involved in the process for how decisions are being made, from your domain experts to your data scientists to developers to IT auditors, legal, etc. And so being able to have this visibility and transparency in your process is really critical. Explainability is also certainly a piece of this. And also trust, your team needs to be able to understand why a particular model is making a certain decision. And you want to be able to accelerate data-driven transformation through your organization. You need to have different stakeholders involved in that. So there needs to be trust. So these are just some of the challenges that you face. And what we're really trying to get to is this future state. And what the future state is that we're really going for, we want to have a common visual language that's understandable by coders, business analysts, data scientists, C-levels, auditors, etc. Ability for teams to collaborate, to have different approaches on a common platform. Easy and comprehensive data access and data pre-processing, being able to get access to the data, make the manipulations that you need, and be able to quickly move that into your model building and to deployment, and then be able to automate all of that. Open and extensible AutoML, both vertical and horizontal, transparent and explainable AutoML, low latency scoring pipelines, and algorithm independency as well. And automation and optimization are built in, so you can set it and forget it to the extent that you prefer, automate when you want to, and not automate when you want to, having that flexibility. And then manage deployment and end-to-end production. So this is really what we're trying to get to and why we came together for this joint solution. When we say end-to-end production, this is what we really mean is this kind of this cycle of data science creation and data science operations and deployment. With this, the solution we're addressing is not only the creating of data science and ML models, but going all the way through support and supporting validation, deployment, optimization, and iteration. So really, this is a living, breathing cycle. And I've talked a bit about now the challenges and benefits for a few minutes, but I haven't provided much detail of what we actually have launched and is available today. So what is the solution? The joint solution between KNIME and H2O.ai is a solution providing end-to-end data science with decisions powered by best-in-class AutoML, powered by open source. And what that means in terms of product is an integrated visual experience from data access and pre-processing to production utilizing KNIME Analytics platform, collaboration, automation, and deployment into production using KNIME Server, and then open and extensible enterprise AutoML from H2O Driverless AI. And there are many deployment options available via KNIME and H2O tools. And those tools and the capabilities that we've provided manifest themselves in the product as a set of KNIME nodes that push or pull from KNIME and Driverless AI by H2O, and we'll cover these in detail in the demo. So without further ado, I'd like to hand this over to Stephen Ronner, who will go through the demo from KNIME, and what we'll cover are the intro to KNIME Analytics platform, building a full data pipeline in KNIME utilizing H2O Driverless AI for modeling, the introduction to H2O Driverless AI, which Stefan will do, and automating the data pipeline to run on a schedule in KNIME Server, and deploying the created models into production as REST APIs in KNIME Server. So I hope you enjoy this demo. I certainly will, and I hand this now over to Stephen. Thanks so much.
Cool, thank you so much, Paul. So as Paul just said, we do have a few things to go through in this demo. So without further ado, we'll get started. Cool, so just to start off with, we understand that in this webinar, we have a lot of user base from the H2O side and from the KNIME side. So what I'm going to do is start off with just a brief introduction of what KNIME Analytics Platform actually is, and then we'll jump into the joint solution. So just to start off with what you're looking at, this is going to be KNIME Analytics Platform, the client tool, and this is our open source aspect of our tool. So anyone can go and download what you're seeing on my screen right now. Just a brief tour of the UI. In the middle, we have our workbench, and this is going to be where we create any kind of data science pipelines or any kind of machine learning processes or kind of ETL processes that all work together in the pipeline. On the top left, we have our KNIME Explorer, and this is going to be the different mount points that we have and the different repositories that we have that are going to store our workflows, any data sets we might have, like flat file data sets. We also have the ability to save models and components, which are kind of pre-packaged pieces of workflows. On the bottom left here, we have the node repository, and this is going to be kind of the meat of KNIME as a tool, right? Because everything you're going to do is going to be through these nodes. And just to kind of show you how this is going to go, I'm going to start by making a brand new workflow. So within this repository, I'm going to create a new workflow. We're going to call it new workflow. And from here, we have an empty state. So just in kind of any data science pipeline, the first step is going to be, bringing in data. In this case, for what we're going to show today, we have credit card data. And what this data is going to be used for is to predict any kind of defaulting for a user. So what we have is a few different data sources. So if I want to start off with bill history, one thing I can do is just drag it in. What KNIME is really good at is automatically finding the appropriate node. We're bringing in different data sets. And for every single node that comes up, we're going to get this dialog window. And this is going to be a way to configure the function that the node is doing. So in this case, it's reading in a file from this location. And this is going to be a preview of the data. So as long as I look through and everything looks fine, I can hit OK. And then from that point, within these nodes, we're going to have 3 execution states. A red means that it hasn't been configured yet. A yellow means that it has been configured, but it hasn't been executed yet. And then a green means it's been executed. So if I right click on this node and go to execute, this will execute the function of the node. And then from that point on, the output of the node is available to look at. So this black triangle here is going to be the output of the node. So if I right click and go down to the file table, this is going to be the output of the node. And this is going to be a view of the data set at this point in the workflow. So just to show you a bit more of how quick you can jump into the tool, let's say I want to also bring in my demographics data set. It's going to be the same process. I can hit OK, execute that, and now I have 2 data sets. And let's say I want to join them in a typical fashion. I'll look through the node repository for an appropriate function. In this case, I'm looking for the joiner. What I'm going to do is pull this in, attach the outputs from the executed nodes into the new node. So since we're joining 2 data sets, it needs 2 input data sets. And from that point, we're going to go in and configure it. And with any join, what we're going to need to do is add a matching criterion. So in this case, we have the ID is what we're going to be joining on in this data set. So I'm going to hit OK, and now execute this. And now we're going to look at the output. So now the output of this joiner node, you can see that we can look at the data set from a join perspective. So now we have the bill count information, and we also have the demographic information. And what's very interesting about this tool, and a very important point, is the data is accessible at any point in this workflow. So if I want to debug or look into a problem or any kind of issues I'm having, I can go back through the workflow and look at the different points and the different nodes and look at the execution at that point. because it will say. So for example, I can still look at the execution from this node and look at what that is outputting, and then look at this difference to this one. So that really helps with the debugging process, as I said. So from that point, if we want to get into ETL, there's a lot of different functions. I'll do a simple one like a column selection or column filter. So in this example, I'm going to click through and basically choose which columns I want to keep. So I'm going to get rid of these 2 columns because they're entirely too unique for what I'm doing, and I can execute at that point. So what I just showed is very simple. This is just showing how you can basically drag in these functions, search through the node repository for what you're looking for, and start to work on an ETL process. However, as anyone in data science knows, these things get very complicated very quickly, and there's a lot of different ways to do all these different steps. So now I'm going to jump into the main portion of the demo. And what we're going to do is we're going to actually build a full data pipeline in KNIME utilizing driverless AI for the modeling technique. So what you're looking at is a completed workflow. And what it does is going to have these different annotation boxes for the different sections of the workflow. So as we can look through, we have different stages of the pipeline. This first box is going to be our data ingestion and joining phase. So as you can see, before in the last workflow I showed, it was just 2 flat files. But in this example, we're showing that KNIME can support many different data types. For example, this top branch. So what we're doing is we're joining 4 tables in this box. The top branch is going to be bringing in the demographics data set from an S3 bucket. So what I do is I have to authenticate against Amazon using credentials, or in this case, I'm using my default credential provider chain. From there, I'm connecting to S3, and then from there, I'm going to read in this file from S3. Just to show how simple it is, it's just a 3-node process. Now, if I look at that execution, I do have this data set being pulled in from S3. This next branch is going to be a flat file being read in, as I showed you before. These bottom 2 branches are unique because we're actually showing a connection to a database. In this case, it's SQLite, just because for the demonstration, I wanted to make it simple. But if we look into actual database nodes on the left, you'll see that we have connections to many different database types. But what you're seeing here is 2 different ways to hit this database. On the top branch, what I'm doing is, let me connect the database first. The top branch, what I'm doing is just hitting it directly with SQL. So that is possible. And if you want to use SQL against a database, that is possible. This is a very simple SQL command. It's, just select star. But this select query can be a lot more complicated. And what's really cool about our tool is what's happening within these. Instead of having the black triangle as an output, we have these red triangles, which is essentially saying that this execution is being done in the database. So when I run that SQL command, it's being sent to the database and giving me a response and sending it back to KNIME with this black triangle. If you don't know SQL, or if you have analysts that aren't as good as SQL, it's still possible to do it without coding. You can just go in and select a table, and they'll have different options for you here. So I showed 2 different ways to read in those data sets. And now we have 4 different data sets. Another important piece that I didn't mention is if I want to execute something upstream, KNIME will take care of it and it will basically run everything behind it downstream. So if I want to just get started and join all these, I can execute the end join. It'll execute all of the nodes previously to it. And now if I look at this, I have a full, completely joined data set of all of these 4 tables. So from here, we're going to get into the next box, which is the pre-processing. And as you can see, another important point is the color differentiation. So in this case, orange is going to be ingestion of data, and then these yellow nodes are going to be more kind of ETL processes or manipulation. So in this first example, we can see number to string. And what's happening here is we want to ensure that these certain categorical variables are not being treated as integers. So for these 4, sex, education, marriage, and the target default, we want to make sure they're coming in as strings. So I'm going to change those, run it. And now we can see in the data set that those either Boolean or categorical are now being treated as strings, as I told it to. For column resorter, all I'm doing is telling it I want the target at the end for my own use. For missing value, it'll go in and it will find for any strings that are missing, you can tell it the appropriate action. For numbers, I'm going to take the median. And this numeric binner is pretty interesting because in our data set, we have an age category. And what we want is we don't want it to be continuous. What I want is it to be categorical. So what I'm going to do here is I'm going to make 3 buckets. So any age that is from 0 to 30 will be considered young. Anyone from 30 to 50 will be considered middle-aged. And anyone over 50 will be considered mature. So now you can see if I execute this node, it'll go through the previous nodes. And now I can look in my bin data. And at the end, you'll see that we have this age bin category, which now has the appropriate categorical attributes. I keep going. Column filter, as I showed you before, will get rid of certain columns. What I'm going to do here is I don't want our model to get confused because it has very correlated features, such as in this case, age will be correlated with the age bin, so I'm going to get rid of it. I also want to get rid of the ID because it's too specific. And then from there, we're ready to start the actual model building process. So this next node is going to be partitioning, and this is where we're going to do our test train split. We open this up, I'm doing a relative split and I'm saying I want 80% in my training and the remaining 20% will be in my testing. So what we can do is if we right click, we can look into the different partitions. The first one will be 80% and the second one will be 20%. So from there, we're going to go into the actual model training aspect of the tool or of this workflow. So what's happening here is now we're actually invoking H2O Driverless AI. Everything before was in KNIME, but now we're getting to the point where we want to utilize the Driverless AI experiment feature because, you know, as a data analyst, I want to utilize their algorithms to help me, you know, build a correct model or build an accurate model. So from here, what we're doing is we're sending the data to H2O Driverless AI, an instance that I also have. And then after I upload the data to Driverless AI, I'm going to send it as an experiment. So I'll go ahead and execute this. So now this process is showing me the, how it is sending the data into Driverless AI. This may take a second depending on how large your data set is, and also just the process of sending it from machine to machine. And then when that process is done, I'm going to start a Driverless AI experiment. And you know, depending on your experiment and how you configure the experiment, which Stefan will go into more detail when we switch over to Driverless AI, this could take from a few minutes to maybe an hour. So there is a different process here. So I'll wait for this Driverless AI instance to execute, or upload Driverless AI to execute, and then I will send or initiate the experiment. So at this point, we have a green light, meaning the data is now in the Driverless AI instance. And from there, I can go ahead and execute this experiment. So as I said, this might take a minute. So at this point, I'm going to go ahead and allow Stefan to take over, and he'll show you what's happening behind the scenes and what's actually happening when an experiment is being run on data within Driverless AI. So Stefan, off to you.
Thank you. So I'll just wait to have the sharing option. Okay. All right. So at this point, Stephen has kicked off an experiment that that is running inside of Driverless AI. So I'm able to see that experiment now currently being at 10% done here in Driverless AI. So let me just open it and tell you quickly what it means and what is actually happening when an experiment is being built. So you might wonder why we call it an experiment and not a model. So throughout the experiment execution, large number of models are being built, and in order to achieve the best accuracy of your final model. So the steps that actually precede the creation of your final model are looking at for Driverless AI step looking at the data, trying to find out whether the data is consistently structured, whether there is no data leakage with respect to targets, and basically making sure that the data is pretty consistent. Then the next step, Driverless AI will try to find the best model or set of models that suit that are most suitable with respect to the data set on which the models are being built, deduce the best model parameters, so doing the hyperparameter search. And then the main portion of the model building process is an iterative process, which is actually being depicted here by those yellow boxes on the bottom left-hand side corner of your screen, showing the progression. And I hope I'm actually sharing my screen.
We can see it.
Yeah, okay, that's brilliant, because this just jumped out the control panel. Yeah, so in the variable importance chart, you can see if I hover over various boxes, which are individual models, that the variable importance chart changes. And this is due to the fact that throughout all of those iterations, we are Driverless AI is trying to come up with the best set of features that leads to the best model possible. And that is being driven by a genetic algorithm, which intelligently navigates Driverless AI through the extremely large search space of all the feature transformations that are possible to be generated. And this way, we are able to figure out the best set of features, train the main model, or rather, in most cases, the the set of models that are then blended into one big model. Now, this is now you're looking at a screen with a experiment that has finished. Throughout the experiment, you're able to see some statistical informations, like you're observing your ROC curve and seeing various cutoffs and the respective confusion matrices, and different other statistics, as well as the summary when the model is being finished, where you can see how long everything took, how many models and features were taken into consideration throughout the model building process. There's much more detailed output when it comes to scores and intermediate scores for the candidate models, which were not selected, and there's a whole bunch of notifications, making sure that that the end user gets the best possible guidance throughout the machine learning process. Now, there's also an alternative workflow that makes sense using the integration between KNIME and H2O, and that is by starting one step earlier after the data has been successfully created and put together inside of KNIME and sent to Driverless AI. So you remember Stephen was using the node sending data to Driverless AI, which resulted in creation of this particular data set. So you have probably noticed that that in KNIME it is possible to set up a couple of parameters for the experiment, and actually there's no need to leave that environment for any particular reason, unless you want to go and set up many more parameters for the experiments in question. So what all you can do throughout, if you decide to spend a little bit more time in the Driverless AI user interface, so using the data set created and pushed to Driverless from KNIME, you can check the details, see some statistical overview of the structure of your data set. Then you can click on Visualize and generate automatically a visualization for your exploratory data analysis. So this way, you're able to see how the data is being created. You're able to see some interesting information about the distributions over your columns. Maybe check for outliers that are automatically discovered for you. Check the correlation graph to see. You can filter the strength of correlation. You can always download all of these charts if you want. You're able to automatically identify some clusters in your data and see how the particular values of individual features are linked to clusters in other feature columns, etc. So once you're done visualizing, you can kick off the experiment from within Driverless AI itself as well by clicking on Predict. And here you can select. You obviously have to tell Driverless AI what's your target column and what's going to be predicted. And from here, there are these three numbers, which are relative weightings of accuracy, time, and interpretability, which are exactly the same numbers that you have to specify in KNIME when kicking off the experiment. Accuracy determines how complex the model would be, how much we strive to reach the most accurate model. The trade-off, obviously, is that there will be very complex cross-validation schema being applied, and also blending various kinds of models into the final pipeline. And then also hand in hand comes time setting. With longer time, with the higher values of time, higher number of iterations in the already mentioned evolutionary algorithm will be employed, and higher number of individuals for feature engineering and hyperparameter tuning. There's also a counter correlation when it comes to interpretability. So there is a little bit of competition in accuracy and interpretability. In terms of increasing the interpretability leads to pruning the feature engineering search space. So we will not be able to use the most complex transformations for generating new features. And also we will be able to imply monotonicity constraints on various columns, etc. Well, should this not be sufficient level of detail, there is expert settings tab, and I'm not going to spend much time here, but I'm just going to say that you have the freedom to tell which types of algorithms will be employed, how these algorithms would use their default values for tree algos, just maybe defining the way how the trees will be built, and to which of the approaches would be taken, time series, NLP, all kinds of really detailed settings. Now, if I launch experiment, I will get to what was already being shown. I just may click on it, and you will see what I didn't have time to show in the beginning. So these are the elementary steps at the very beginning. Now, if you have an experiment that is already finished, you may recall that Paul was talking about one of the values being trust. Now, we do address that in Driverless AI using our MLI module, which is model interpretability, machine learning interpretability. What that does is taking your final model and generating tons of predictions and training auxiliary models around this model in question, in order to shed light on the internal functioning of the model that we have generated. This way, let me just open some of that screen. So this is, for instance, a sensitivity analysis tool. This allows you to really debug the functioning of the model, see how the model operates on unseen data, how the model is behaving when it comes to different inputs and subsamples of the data set, and really see the structure of predictions, etc. Another very important module would be disparate impact analysis. So in this case, I have selected, so the data set that we are looking at is a data set for credit card defaults. So you might be interested whether your model is fair with respect to sex or marriage or education, and this module actually addresses those questions. So this is how we address trust. We could spend much more time there, but at this point in time, when I come back to the overall workflow, what I have shown you is that you can either intercept the workflow from KNIME at the point in time when you have your data set ready, you upload it to Driverless AI, you generate the experiment, and you make sure that the experiment is sane and it makes sense. It is well built, and it corresponds to the reality that it is modeling using the machine learning interpretability module, and then go back to KNIME. Or you can actually you do not need to leave KNIME whatsoever. And I was just only showing how the model is being mirrored on the system, on Driverless AI system. So this concludes the explanation of what happens behind the scenes, and now it's time to go back to the workflow in KNIME. So over to you, Stephen.
Cool. Thank you very much, Stefan. So as Stefan just showed, when we utilize a driverless AI experiment, what we're doing is, taking advantage of the algorithms and the code that H2O has created to help kind of take some of the hands off of your machine learning building or algorithm building process. So now that the experiment has concluded, we have a finished experiment here. And what we can see on these two ports are going to be the diagnostics of the experiment and the actual model object itself. So if I hover over it, it will say the mojo, which is how they store their models. So if I right click and go into experiment summary, we can look into some of the metrics on this experiment and how it performed, such as accuracy, AUC curve, and things like that. So now at this point, we've run the experiment, and now we want to get into the actual deployment aspect of the tool. So there's different ways we can do this. What I'm going to do, just to keep it simple, is I'm going to just write the model on my local mount drive here and give it a location. And then also down here we have model scoring. So another one of the driverless AI nodes that we've implemented in this integration is going to be the actual implementation of the model. So what's happening here is we partition, we made a test train split. The test data set was sent to driverless AI to run an experiment. And now we're using that experiment result to actually apply this. So if we go into this now predict data, you can see that we have the original data set, and now we have 3 new columns here. So we have the prediction of what it's expecting for defaulting, and then we have the prediction of the different categorical values here. So it's saying the probability that the default equals 0 and default equals 1. And then also we have the score node. So if we, in this point, we can use an interactive view, which will open a view within KNIME and show a confusion matrix and basic statistics about the algorithm. Keep in mind, we're using a smaller demo data set, so any kind of accuracy statistics or anything are based on that. So now we get to the next point of the demonstration, and we're going to start utilizing KNIME Server. And what we're going to do for the next 2 portions is I want to basically productionize this workflow, and I want to use this model in production. So what I'm going to do is first send the data send the workflow to KNIME Server to allow it to be an automated process. And then from there, I'm also going to build a REST endpoint around this model to where we can actually hit it from external applications. And just to start at the end of this process, just to show you the ending of what we're doing. So this workflow, what it's doing is it's taking the validation data set. And if we look into the validation data set, it's the same data as before. It's a partition of the data before, except we've got rid of the actual target. So this is going to be live data that doesn't have an actual default value, and we're trying to utilize the model to see to give a prediction of defaulting. So what's happening in this is we're connecting to my KNIME server, which I've built a workflow that will allow REST connection. And then I'm going to use the call workflow node to send the data set via REST into that app or that workflow and get a result. So if I execute this, what's happening is it's sending the data to my server, running a workflow there, and then returning the results. So now if we look at the output here, we'll see that the data types have changed because the workflow on the server has modified the data. And then also we do have the predictions and the probabilities as well. So now to show how to build this and how to actually implement this using KNIME Server. So on the left here, we have our KNIME Explorer, as I said before, and we have our two mount points. So I have my local mount point and my KNIME Server mount point. So everything I've showed you so far was done within KNIME Analytics Platform, our open source tool. But once we want to get into the automation and productionization of our workflows, we'll have to use KNIME Server. So what I'm going to start off with is I'm going to take this workflow I built and I'm going to go into deploy to server. From there, I've put it in this demo location under the H2O credit card demo, and you'll see now that this workflow is on my KNIME server. And once the workflow is on KNIME server, there's different things you can do with it. The first thing I'll show you is the ability to schedule and automate this process. So if I want to execute this workflow on the server, we can go into scheduling options. And from here, we can make a scheduled job that repeats execution, let's say once a day, every single day at a fixed start time. So we'll say every day at 12 a.m., we will run this workflow and we'll get a result. So as you can see, the fact that we're writing this model, what I'm doing is I'm storing it in this model location and I'm calling it model latest. So there's different ways you can handle model operations. What I'm just doing is I'm overwriting the latest model just to keep things simple. And as you can see, if I open up the iterations of this workflow, you'll see that I already have built a schedule. And what this schedule has been doing for the last couple of days is running this workflow every 2 hours. So if I open up the schedule, you can see the different iterations of this workflow being constructed. And this is important, especially because if we're dealing with rapidly changing data or hot data, we want to make sure that the new data is being included in our newest models, or else we're going to suffer from model drift and things like that. So what I can do is I can look through at different points of my model creation, and I can look at the statistics based on different times. So if I want to, I can open up this latest model that was created. What this is going to do is open a job on the server. So what you're looking at here is an iteration of this data pipeline being executed on the server. And at this point, I can look in at the different portions or the different steps of the data to see what happened in that particular moment in time. So for instance, this data pipeline resulted in a separate accuracy in a different confusion matrix. So now we have the process of automating a data pipeline workflow. And what we're doing is we're creating a new model at periodic times in the day. And now we're going to get into the next portion of building, productionizing is actually utilizing this model and hitting it with fresh data. So now I also have a separate workflow on my server called REST deployment. And if we look at this workflow, what we're looking at is an API call that we built using KNIME. So what we have here is the container input and the container output. And the input is going to be the API input. So anything we send via the API is going to come in here. And then it's going to apply the workflow, and any output of the API will go out of this side. So what you're seeing here is the data comes in. We apply some pre-processing, read in the current model, which is the model latest, and then apply the prediction. One important thing in KNIME is this gray box is actually called a component. And what I'm doing here is basically abstracting a piece of my workflow. So what I can do is go inside of it, and this is what the component consists of, a few different nodes. So just in case you see the gray boxes, that's what's happening. So within this API call, what's happening is, like I said, we're reading the model, reading in the pre-processed data, applying the model, and sending the results. So then at that point, from my local machine, where I have this workflow, that's where we were able to actually use the data and get some live results. So just to kind of reiterate the first step of what I showed here, we have the CSV reader reading validation data from Amazon that has no target attached to it. And then what it's doing is sending the data up to the server and running this, or executing this workflow. And one important thing, just to kind of show you it happening live, if we look at this REST deployment workflow on my server, when I execute this call workflow, it's going to create an instance of a job. So what I'm going to do here is I'm going to change this and say, I don't want to discard the job. I want to look into the new job that was created. From there, if I execute this workflow, you'll now see that on my server is created a new instance where it's running through that workflow. And once it's finished, you'll see that it now has a green status for being a finished job, and we now have the results as an output with our various predictions and probabilities. So cool. So in this time that me and Stefan have been demoing, we've showed an intro to KNIME Analytics platform, and then from there we built a full end-to-end productionized REST API wrapped model from the process of developing the actual data pipeline and workflow to deploying it to the server, automating execution and model creation, and then also deploying it as a REST API. So at this point, that's the end of the demonstration. So I'll go back to the PowerPoint, and if anyone has any questions or any kind of additional points, feel free to reach out in the Q&A section. But thank you very much.
All right. Thank you, Stephen. Thank you, Stefan, for that great presentation and demo. Let's see. First question is, are there any white papers on these use cases for us to take a look?
So we do have some joint blogs that we've written together that we can source in the Q&A, and also if there's documentation on both of our sides of how to get started with this integration.
Great.
I also can mention that both today, there are some, and there'll be more coming soon, to hub.knime.com, where we will post the workflows that we have shown here and are building examples around, so that you can actually open those up and use those as a starting point or a blueprint for experimenting with KNIME and H2O Driverless AI.
Great, thank you. Next question is this a new initiative between KNIME and H2O, or has it always existed?
So we've been working.
Go ahead, Paul.
All right. We've been working with H2O for a few years. So we've had connections to the open source H2O, H2O3, as well as sparkling water in the past. So we've been working with H2O for a little over 3 years now. The thing that's new that we announced here recently and that we're covering in this presentation is really the driverless AI and KNIME Server integration, which is now available. So we'll continue to develop and work on open source and free availability of tools, and as well as extend our capabilities on the enterprise offerings as well.
Great. Does KNIME also support H2O3 and sparkling water?
Yes. And actually, maybe Stephen, it's worth showing the nodes that we have for H2O within the KNIME Analytics platform, if that's easy to do. But in any case, if you just open up KNIME, you can just search for H2O, and then you can actually see the full list of H2O nodes. There's some under driverless, there's some under labs, but there's quite an extensive set of nodes. There's some that access Spark, so you really have a broad array of nodes that are already available.
Yeah, actually, if you go and check out the blog we did with Driverless AI, at the end we have a whole collection of resources. So there's some resources just to learn more about H2O and KNIME and sparkling water and KNIME. And so there's a lot of tutorials and nodes that can help people going, and some previous webinars and meetups that we've done together that could be helpful to folks if you're exploring that.
Great. Thanks, Raphael. And then is H2O Driverless AI free to use and open source?
Yeah, so Driverless AI is a commercial product from H2O. It's leveraging open source, right? So it's helping to automate building, open source algorithms. So underneath the hood from Driverless AI, you're working with XGBoost, LightGBM, TensorFlow, PyTorch, and H2O3 and a whole collection of other algorithms, right? So it's all powered by open source machine learning, but Driverless AI itself is not open source.
All right. And how big
I think
of
it's
data?
worth saying that we have also the trial license for everybody to try for 3 weeks, Driverless AI, and we also have tutorials where you can play with the system.
Great. Thanks, Stefan.
That's actually a good point, Stefan. And what I'd add is that if you want to get going with the two of these products working together, grab that Driverless AI trial, download KNIME Analytics platform, which is free and available. And then if you are interested in the KNIME Server capabilities, you can reach out to us via the links or email partners, PARTNERS @knime.com if you need a free trial of the KNIME Server.
All right. How big of data can we import into the KNIME workflow? Is it only simple CSVs?
There's different approaches here. KNIME can handle a lot of data based on what machine it's on, right? So it's going to use the resources of the client that it's on. So in my case, my laptop doesn't have that much RAM, so I probably wouldn't be able to keep anything very large on it. However, one thing that KNIME is very good at is integrating with other frameworks and sources. So what you can do here is, if we have a big data environment and we're dealing with very large data in a terabytes region, we do have connections to Spark. And also, this goes in line with the databases that I showed earlier. Any kind of, when we're using these Spark nodes, what's going to happen is it's actually going to push the execution into the Spark cluster. So it's a very efficient way to deal with large data sets at that point if we're utilizing these kind of frameworks, or if we're dealing with a large OLTP or OLAP database. What we can do is within the Spark nodes or the database nodes that are pushing the execution, we can run some aggregate functions or bring the data to a smaller format and then do the remaining steps in KNIME.
Yeah, one other thing to add there is that you're not limited by KNIME, and this is in the free analytics platform. You're not limited on the rows and columns of your data. You can use extremely large data within that tool. So if you're trying to do ETL processes to get things into Driverless AI, you will not have limitations there. It's really your own machine, your own compute and storage that are going to limit you.
Mm-hmm.
Okay. What if my experiment has very large amounts of data? Can we limit Driverless AI time on searching to find the best machine learning model?
Yes, you can specify an exact time cap on your experiment runtime.
And can Driverless AI run locally?
Driverless AI can run pretty much everywhere. So there are two major flavors, and that is Linux service or Unix service. And the other option is Docker container. So it is possible to host it anywhere in the cloud or on-premise. We also support Kubernetes, and really it's very flexible, and the installation is next to trivial. So you just download the Docker image or the package for your Unix distribution.
Yeah, but I would add that Driverless AI is server software, right? So when you say local, oh, I have a laptop and I have 8 gigs of RAM, and I want to run driverless, that's not really the configuration that driverless was sort of set up for, right? It's really server software, right? So you want to run it on somewhere where there's enough memory to do the processing and really kind of go through and try all these different sort of algorithms. So there's a bunch of tutorials. You can get started sort of online and use a free cloud environment from Aquarium, or choose your favorite cloud and get started there. But yeah, do give it enough resources, it's going to have sort of success with AutoML with driverless.
That being said, I would still not discourage anyone to give it a very first chance on a decently sized laptop, just to, if this is the simplest way how to deploy driverless, then it works. And obviously keep in mind that for serious work you need serious resources, but it works on laptops too, but it's not designed to do the work there.
All right. Are there KNIME nodes that access the open source H2O AutoML functionality?
So as we showed before, if I could go back into the H2O nodes that we have, this is something that I didn't cover in the demonstration, but KNIME supports extensions. It being open source, we have different extensions that different partners have built, or extensions to other software. And what I've done in my KNIME Analytics platform here is installed all of the H2O extensions that we have. So in this case, we're utilizing sparkling water as I showed, and then also if we're looking, correct me if I'm wrong, Stefan, but if we look into these are all these different model creations in H2O. I'm pretty sure that's what he means by the H2O modeling techniques, if that answers the question. But we do cover a lot of different functionality and connection to H2O, open source, and now their commercial driverless AI.
Okay, can I think of driverless AI complementing KNIME on modeling and KNIME supporting driverless AI on ETL?
Yeah, I think you absolutely can. It really depends on what the best solution is for your specific challenge that you're facing. I think that if you are a KNIME user, you're very comfortable with the KNIME environment, but you want the power of and the interface of driverless AI, that's really going to provide some additional value. If you're an H2O driverless AI customer and you are and you are trying to do some pre-processing data access access things like Snowflake or access things like Salesforce data or SAP, you get a lot of value from the KNIME software. So I think it really depends. You can mix and match those. There are tools from both KNIME and H2O.ai in a number of different categories. So in things like model building and things like pre-processing and things like visualization, really across the spectrum, model ops, deployment. So I encourage folks to really just use the tools they're comfortable with, explore the others, and find the best of breed solutions for their individual scenario. There is some overlap, but in our eyes, this is meaningful and gives optionality to customers, and that's really what we're looking to do.
Great. Thank you, Paul. So we've reached the top of the hour here. Just want to say thank you to all of our speakers for taking the time today and doing a great presentation. I'd like to say thank you to everyone who joined us today as well. The presentation slides and recording will be made available by tomorrow, and we hope you have a great rest of your day.
Thanks, everyone.
Thank you, everybody.